Hello everyone, welcome to our first lecture on data visualization, one of the most important everyday tasks that we accomplish in data science. So let's start first asking the question in a very general sense of what is data visualization? And let's take a look at this image, which is on our screen, and think for a moment, what is this a visualization of? Try to pause for a second and think what that could be. Turns out, you might not have expected, these are actually where does the ball bounce in a squash court over time. Every time the ball hits the wall, it leaves a mark in there. So this is showing us something about the properties of the game and the dynamics of where the ball gets hit and where it bounces. This is a different visualization. Some of you may have visited this location. What this visualization shows us is the entire list of all the 58,000 plus names of dead soldiers who died during the Vietnam War, and they are arranged in a very, very particular way. The names on this wall are arranged in order of the time of their death during the war. So this is data. This is data that we have about who died during the Vietnam War, but it has also been presented in a very particular way. Choices have been made, aesthetic choices have been made about the material that this is built upon, in this case a type of black granite, how the names are laid out, the temporal ordering of this information, and its placement in the context of, in this case, the mall area in Washington, D.C. and its location with regards to the Washington Memorial. These are choices in how we present this information to convey certain aspects of what is happening here. And those choices are important. Those choices are choices that you will have to make whenever you make a data visualization. It may not be of something that carries the connotations of thousands of people who died during armed conflict, but at every point in your presentation of data, you will be making choices that impact how that information is conveyed in the end. So this is a way of seeing that data visualization is something that is both connected to basically the raw data, but also where many other choices that you will have to make come into play. So some more kind of academic definitions of visualization are these two from different points in time. Visualization as the use of computer-generated interactive visual representations of data to amplify cognition, or finding the artificial memory that best supports our natural means of perception. So there's three elements here that I want to highlight from these definitions: perception, cognition, and artificial memory. Artificial memory in this case I think refers in a somewhat generic way to computational tools. Keep in mind this was a definition from the 60s when visualization, we didn't have at all the modern computational visualization tools, but there was an idea of encoding data still in visual forms. It could have been done by hand. In our case today, those tools are computational, but the important point is the connection between perception and cognition, the idea that we're using our visual perceptual system to understand, to think about data. And we're using means, artificial, computational, graphical means, to make that connection. And the reason is that our visual perceptual system is one of the most sophisticated pieces of machinery we have in our brains. And in general, we tend to be able to see patterns. We tend to be able to grasp the structure of data much more easily by visual means than purely by looking at raw numbers. It is useful sometimes to look at your raw numbers, and I encourage you always to look at summary statistics and to look at just the raw data a little bit, because sometimes things jump out at you from the numbers that may not completely be obvious visually. So these are complementary things, but in general, we are able to absorb a larger volume of information if we encode it visually. This is an example of grabbing grabbing many ages and then showing them, instead of as a table, showing them like this. And very quickly, by looking at this, I can tell that the age distribution ranges from 0 to about 80, and roughly that other than in these higher age brackets, there's a reasonably even distribution of ages across that range. That would be much harder to tell, for example, just by looking at the table of data. Even if I had them all here, it would be much harder to find, for me to find what the maximum is. I would have to basically scan them all. So visualizations are absolutely built for humans, though obviously you can begin thinking about machine ways of extracting information from visual data. But let's concentrate for now on the fact that, by and large, and at least in the context of this course, we'd be talking about creating visualizations for human to consume. In this example, I can quickly, by encoding fair data across ages, in the case, for example, of transportation data, I can quickly, by looking at this scatter plot, and we will come back and revisit these types of plots later, I can quickly say that it doesn't seem like in this particular data set there's any strong correlation between the age of the travelers and how much they spent on their fares. That's something, that kind of relationship would be very hard for me to make quickly by simply looking at a big table of data, especially because this seems to be a relatively large table. So what we often say is visualize, then quantify. Basically, get a sense of your data visually and use that as a first sanity check before you start making quantitative statements. This particular example is a classic from descriptive statistics called Anscombe's quartet. And what we have here, and we can load these into Pandas very easily, are four different data sets that all happen to have the exact same descriptive statistics, some generic summary statistics, such as mean, standard deviation, and correlation coefficient. These data sets have been carefully created for those statistics to be the same, such that if you were to fit a linear model, which we will learn how to do soon in this class, to these data sets, you would obtain the exact same fit from all of them. And yet, these data sets, by looking at them, have a very, very different structure. This is one where there seems to be a roughly linear relationship between the data, but with some noise. This seems to be a data set that encodes a perfectly linear relationship here, but with one single outlier point that would lead to a different line, probably that would look something like this. That would be the same line that we have in here. And yet, probably anyone would argue that in this particular data set, it seems like this is for some reason an outlier, and you might want to take a look at whether that outlier is valid data or there was, for example, a measurement error, and then in this case the actual true model for the data should be something completely different. This is a case that would lead again to the same linear model as this one, but clearly the relationship for this data is not a linear relationship, and you should consider doing a fit of a different kind. And this is an example of data for which you have absolutely no evidence of a linear model, in particular because basically all of your data was acquired at a single point in X. By having just this one point out here, you can get the same linear model, but you have absolutely no evidence from the data in that direction. Now, this is a bit of an extreme example, but I encourage you to look on Google around for the Datasaurus dozen if you want to see even more extreme examples of this kind of problem. Now, the point is that visualization goes hand in hand with statistics. We will learn how to model. We want to analyze our data quantitatively. Very often you need that. And sometimes knowing what to visualize in the data is not as clear and straightforward as in this example, but they are still both tools that you will need to use hand in hand in a complementary way. So, if we think of the big picture goals of data visualization, there's probably two aspects that are complementary in data visualization itself. One, which is the kind of thing that we were looking at in this past example, is to help you with your own understanding of your data or your results. In this scenario, visualization is a key element in exploratory data analysis. You should use it to validate your models as you go along. And the point is that this is a lightweight, iterative usage of visualization tools. You tend to use them a lot. You plot things as you go. You don't pay too much attention to fine-tuning your plots or making them particularly pretty or elegant, as long as they give you the information that you need as you're going along. So this is a tool that you use while you're thinking. At some point, you might actually have results that you need to convey and communicate to others. And for that, you may want to build a much more polished visualization. In this case, visualization becomes a highly editorial operation. This is a case that is a little bit more akin to the one from the example of the Vietnam Memorial, right? Where you are now making a highly editorial set of choices about how you present your data. You want to convey something, you want to highlight aspects of your reasoning, aspects of your model, you want to focus the attention of the viewer on certain features. You need to be thoughtful and careful in that process. It is possible for a visualization to actually skew that focus of attention to the point where you are misleading the viewers. And so when you're really building a visualization for someone else other than yourself, and you are now making lots of editorial choices in the fine-tuning of your plots, then you really need to both balance what it is that you're trying to communicate with whether you are pushing those editorial choices beyond what your data support. And in addition, when you reach that point, this becomes a much more time-consuming task, because data visualization at that point bridges into elements of visual design and even of art. This is an example, and I encourage you to go and visit that, of the John Hunter Excellence in Plotting contest. These are a few of the winning results of highly both aesthetic and informative scientific data visualizations that have been done over the years. So why do we want to visualize data? Because one of our goals with data science is not only to understand things, but actually to help inform human decisions, and plots help us directly in that regard. But as we're going to discover, it's not as simple as having a raw data set and calling plot on it. Every visualization has trade-offs. There's many plots you can make, but only some of them will be informative to you. And so we're going to try to dive a little bit into that, learn which types of visualizations are useful for the kinds of data that are most common, at least in this course. And in the next lecture, we'll discuss some more general principles of visualization, alongside with kernel density estimation and transformation. So we'll stop here before we move on to the next topic.